Hello everybody, today we're going to be doing another video, and this time I'm going to be doing it on two things, how to find the distance between 2 points, and we're also going to be doing how to find the midpoint. So I have this little diagram here. It's actually a screenshot from desmos.com. And I have two simple points on here with a line drawn through them. 0.76, and this is the x-coordinate where my cursor is. And this is the y-coordinate. Same here, x-coordinate, y-coordinate. So we can call this point A, and we're going to call this point B. Nothing too hard to understand there. And I drew a little line through them, and we're going to try to find the distance of that line. But a simpler concept might be, well, what's the coordinate of the point right in the middle? Now, this isn't essential to finding the distance, but it's something that your algebra teacher might ask for instance. And so, how would we find maybe approximately the midpoint is right there? So how would we find that? And it's actually pretty simple. So what you would do first, to find the midpoint of 2 points, what you need to do, you should probably set it up like this. Since it's going to be a coordinate point, what you need to do, you may as well set up the coordinates. So you have your x-coordinate here, your y-coordinate where my cursor is right now. And so how would you find it? So all you really need to do is, for the x-coordinate, take the average of the two x's. For the y-coordinate, take the average of the two y's. So how would this appear on, and I'll move this line over here. So how would this midpoint, what would be the coordinate of the midpoint? So we're going to do that right now, and we're going to take the average of the two x's. That's going to be 7 plus 8 divided by 2, because you have exactly 2 points. Now, what would be the average of the y-coordinates? Well, it would also be divided by 2, since there are 2 points. And it would be 9 plus 6. And if you consider what average means, no pun intended, but what average is essentially it basically gives you the center when you have 2 points like this. And you could also apply this to more points. For example, what if I had a triangle here, or just 3 points somewhere? What if I put a third point maybe right here, for example? And let's say you know the coordinates, and this would actually be like 2, this one would be 2, 8. Sorry, the point is kind of small, make it a bit bigger. So right there is like 0.28. Let's say we wanted to find the midpoint of these 3 points. And I don't believe, and yeah, it would still be called the midpoint. And so it would be maybe, I don't know, somewhere right here. Who knows? But you'd have to calculate it. But you'd have to be careful at that point to make sure you divide it by 3 instead. And you add up all the x's. So it would be 2 plus 8 plus 7 divided by 3. 8 plus 9 plus 6, also divided by 3 to get the x-coordinate, the y-coordinate of the triangle's midpoint. But back to the line here, you can do this right here, and this is going to be 7.5, and up here, and over here, sorry, you're also going to have 7.5, surprisingly. I did not intend for that, but yeah, apparently it's 7.5, 7.5, so that would be the midpoint for this line right here. Also, I also wanted to cover, I'm going to erase the midpoint stuff. Hopefully you got it. You can just rewind the video if you want to see the old stuff. But now what if we were to try to find the distance between these 2 points. That's a bit more complicated, but I've covered the Pythagorean theorem. So just as a hint, see if you can try to solve it using the Pythagorean theorem. And so if you look at this, and I'm assuming you've tried it out yourself, we draw a triangle here. Sorry, it's going through the where it's written as a coordinate. You can see that this is a right triangle. And now I didn't draw it perfectly, but if I did, it would be a right triangle. And the distance between the 2 points in question is actually the hypotenuse of this right triangle. So how do we find and we know with Pythagorean's theorem, the Pythagorean theorem, you can use any two, you have to have both of the side lengths, and you can solve for the other side of the triangle. So we're trying to find out this side right here. If we knew what this side and this side, what their lengths are, if we knew that, we could solve for the distance. And how might we go about getting this, you might ask? So what we would do, we know that this is 0.76. We know that this is 8,9. Now some of you might be tempted to say that this has a height of 9 because the y-coordinate is 9. Now that's not, no, it is true in one respect, but not true in terms of what we need for this problem. We need the height right here. 9 is the height from here to here. So we need to find this minus the y-coordinate of this. 9 minus 6 should give us the right answer as to what is the length over here. We can apply the same concept to find the difference between the x's. 8 minus 7 is going to be 1. 9 minus 6 is going to be 3. So we know that, let's say that a is 1, and we're going to have b as 3, sorry it's a little big, and make this a bit bigger. And so that would equal c squared. And you can solve this on your own. You know, take the square root and then solve for this. This would be like root 10. Root 10. So the distance between this would be root 10. But what I really want you to understand is that there's a formula for this, and it's a bit complicated. But if you really understand what it's saying, and if you understood this diagram, what I was talking about here, it should be pretty easy to grasp. So d squared, and we're going to use d to represent the distance. And essentially what we're doing is just rewriting the Pythagorean theorem into terms which are a bit easier to understand. Actually, I'm not going to write d squared. We're going to write root, and I'm going to put some parentheses, and you'll see why in just a second. We're going to do squared. Remember, we're essentially doing the Pythagorean theorem right here. What I did is, since I'm trying to find the hypotenuse for the distance, I'm taking the square root of the rest of the thing. And let me just do this. And so this is what I have here. And for the hypotenuse, I'm just representing it as d for distance because we're trying to find the distance between the 2 points. So what would we put inside for a and b? Well, what did we do here to get a and b? We did x of one point minus the x of the other point. So if we put that right here, so we have x minus x. Now, that doesn't help too much. So what we do to kind of differentiate them, because they're different points, they're not the same, we sometimes try to put these things called subscripts, and we might say x1 minus x2, y1 minus y2. Now you might be wondering, and an interesting nuance to this would be that what if x1 minus x2 is negative? Let's say we go back to our example here. What if I did 7 minus 8? Let's say this was the last point, this was the first point. In my prior example, I used this as the last point. This is the first point. I took this point right here where my cursor is. I took this point first, then I took this point. What if I did it the other way around? Now, if you know exponents, if you know how to square anything, or if you know this thing about even exponents, it's that if you take anything to an even exponent, it'll be positive, always, unless of course there's a negative sign in front of it. But if you do that, so let's try it right here. So let's say we did 7 minus 8. 7 minus 8, we put it in here. What would we get here? 7 minus 8 is minus 1. Minus 1 squared. And if you know what squared means, it's just minus 1 times minus 1, which is positive 1, because two negatives make a positive. And so it doesn't matter which order you take them in, because this square will always make sure that it stays negative. Then when you take the square root, you can find the distance pretty easily. Hopefully this helped you find the distance and the midpoint and the formulas for it. And just for good measure, I'll write the midpoint, and we usually tend to write this as point M. Oh, sorry. Okay. Alright. So M, and this is the midpoint formula. I'm just writing it down here. We're going to do x1 plus x2 divided by 2, also divided by 2, and we're going to do y1 plus y2. And that is it. Thank you for watching.